Hello friends, we will be studying magnetic flux and let's start. So what basically magnetic flux is? It is the number of magnetic field lines passing through a loop or a surface. Okay, so it represents basically the number of lines passing through the surface or the loop. If B is the magnetic field and D is the small area, then small flux can be this. And if field is uniform, then we can take out B out of integration and total flux will be B dot A or BA cos theta, where B is the magnetic field, uniform magnetic field, A is the area, theta is the angle between magnetic field and area vector. And the unit of flux is Weber, which is equivalent to Tesla meter square. Okay, field into area means Tesla into meter square. So that is equivalent to Weber. Okay, sometimes Tesla is also written as Weber per meter square. Okay, so don't get confused by the new unit of magnetic field, which is Weber per meter square. It is also a standard unit. Okay, so let's start with the first example. If a disk of radius r is placed in a uniform magnetic field B, find flux if B is parallel to the disk. Okay. Again, this point is to be noted that it is the angle between B vector and A vector. A vector is outward normal. A vector is outward normal. Okay. So if this is the paper and area vector will be out of this paper, coming out of this paper. So the first example is B is parallel to the disk. Let us assume that this is the disk and this is its area vector. Obviously it will be perpendicular to the disk, but B is parallel to the disk. B is this in the first example, so obviously theta will be 90 degree and hence flux will be 0. Mathematically cos 90 is 0. You can also see it by a simple logic that assume field as light rays. Okay, and if those light rays are parallel to the sheet, those rays will not be able to cross the sheet. Okay, they will not be able to penetrate through the sheets, so no field lines will pass through the sheet as they are parallel to the sheet, so the flux will be 0. In the next case, the field is perpendicular to the plane, means this is the direction of field, area vector is this, and as both are parallel we can write theta as 0 and the flux will be maximum, which is BA or B into pi r square. Third is magnetic field makes an angle 30 degree with the sheet. Okay, remember it makes an angle 30 degree with the sheet, but the angle between area vector and the magnetic field will be 60 degree. So here theta is 60 degree, and when we'll solve using BA cos 60, you will get BA by 2. Okay, so parallel 0 flux, perpendicular maximum flux, and this BA by 2. In the next example, there is a square loop of area 100 meters square which is placed in uniform magnetic field given by 2I plus 3J plus 5K. You have to find the flux if the sheet is in XY plane or in YZ plane and in XZ plane. Okay, let us assume the first example. The sheet is in XY plane. Okay, the sheet is in XY plane. This is X axis, this is Y axis, and this is Z axis. This is how sheet is placed. So as the sheet is in XY plane, the area vector will be along Z axis. So it will be written as 100 K cap. Hence the flux, which is B dot A, as the field is uniform, the flux will be B dot A, and it will be written as 2I plus 3J plus 5K dot 100K. So we'll get only 500. These two components will give you non-zero and other dot product will give you a 0 value. Okay. Similarly, if field is in YZ plane, area vector can be written as 100 I cap hence the flux will be 100 into 2I, that is 200 units for Weber. And C, the area vector will be along sheet is in XZ plane, so area vector will be 100 J cap along Y axis, and the flux will be J cap is 3, so it will be 300 units of Weber, provided field is in Tesla and area is in meter square. The next is the solenoid of cross-sectional area 50 centimeter square has a length of 2 meter and has turns 100 turns per unit length. Find the flux through it if 5 ampere current passes through it. As we know, magnetic field due to a long solenoid is mu naught Ni, and we can consider it to be uniform inside it, so that will be mu naught. N is 100 turns per unit length into I is 5. So the magnetic field is 500 mu naught. We are not putting the value of V naught. Okay, so this is the magnetic field. Now what is the flux? Flux is total number of turns, how many turns are there, into flux through each turn. Flux through each turn, that will give you total flux. So there are how many turns? There are 100 turns per unit length and there are 2 meter of length, so there will be 200 turns into flux through each turn is B into area of each turn, so that will give you 200 into magnetic field is 500 mu naught and area is 50 centimeter square. Just be cautious about the units, so that will be 50 into 10 to the power minus 4 as in meter square. So we will get 5,525 into 2, that is 50, and this will be taken care of into 10 to the power minus 4 will take 4 zeros, it will be 1 mu naught. So 500 mu naught is basically the total flux.